All right, in this tutorial, we're going to talk about classifying numbers, putting them into these major categories. And there's four big ones that we're going to go over for this. Whole numbers, pretty easy. Numbers that do not need a fraction or a negative to represent its value. Okay, 1, 2, 3, 4, 5, all the way up in the positive direction. You're not allowed negatives, you're not allowed fractions, you're not allowed decimals because you're not allowed a fraction. It's another way to describe a fraction. Integers are whole numbers and their negatives. So, negative 1,000. You are not allowed decimals, you're not allowed fractions in order for it to be an integer. It has to be a whole number, positive or negative. Rational is the first one where you are allowed to use fractions or decimals. Okay, rational, the root word is ratio, and in order for something to be a ratio, you're comparing two different integers, a numerator and a denominator. Could be a decimal, could be a fraction. Irrational numbers are numbers that cannot be expressed with a fraction of two integers. So whole numbers and integers are pretty self-explanatory. Rational and irrational are very close except for one tiny little difference. In order for a number to be rational, if it is a fraction or a decimal, the decimal either repeats, like it starts to cycle through 0.33333333 to represent 1/3, that is a rational number, or it just straight up ends and it has a stopping point, 0.75 for the fraction 3/4. That is a rational number. An irrational number doesn't do that. It doesn't end, it doesn't repeat. Pi is a very commonly used irrational number, 3.1415, and that number just continues to go on forever and ever. Nothing is repeating. Scientists have tried for years to determine if there is some type of pattern or if it ends, and it does not. So, irrational numbers. Our first example is the square root of 5. 5 is not a perfect square, and whenever you take the square root of a number, it is going to have an infinite string of repeating decimals, so 5 is an irrational number. Square root of 5, excuse me. If it was just the number 5, it would be a whole number because it's positive. It would also be an integer. 101,323. Now this is positive. There are no decimals and there are no fractions, so it is both a whole number and it's also an integer. It's also a rational because you could represent it as a positive or a negative. You could represent it as a fraction, 101,323 over 1. But to be as descriptive as possible and as narrow-minded and focused, this is a whole number. Now 3 and 2/3 is a mixed fraction. You have 3, this whole number right here, and then you have a fraction. The entire thing must be in common. So you can't say this is a whole number because there is a fraction present. And the fraction 2/3, when you divide, is 0.66666 repeating. And when you round it to get 7, there is a repeating cycle that constantly goes through the exact same number. So this is a rational number. Okay, you need to be as descriptive as possible in classifying your numbers. While 101,323 is also a rational number, you need to say that it is a whole number because it eliminates the idea of it only having decimals or only having a negative number. This whole number says, nope, it doesn't have any of that. There's no negatives. There's no fractions. Okay?